Lesson 6.2 is about reflections. We're going to transform figures using reflections. A reflection is just a transformation in which a figure flips across a line to a new position. You can think of it like a reflection in a mirror. When you look in a mirror, you look exactly the same as you are, except you're backwards. It's a flip. For example 1, we're going to graph the reflection of triangle DEF across the y-axis. That would be called the line of reflection. We can try two different methods. The first one we're going to do is actually graphing on a coordinate plane. We'll just count the number of units each point is from the y-axis and then plot each new point, that exact number of units, across the y-axis. So keep in mind, this is our line of reflection. It's going across the y-axis, so it's going to flip to the other side of this y-axis. So I'm going to go through and I'm going to count my points. I'm going to start here with point D. Point D is 1, 2, 3, 4 units from the y-axis. So I'm going to go to the other side of it and count 1, 2, 3, 4 units on the other side and name that point D prime. So it's reflected across the y-axis. Same thing with point E. I can count that it is just 1 point from the y-axis. So I'm going to go to the other side of it and count 1 point away from the y-axis and label that as E prime. And then point F is 1, 2, 3, 4, 5 points or units away from the y-axis. So I'm going to count 5 units on the other side. 1, 2, 3, 4, 5. And plot that point as point F prime. So I connect the dots to connect the points of this triangle, the vertices of the triangle, and I get triangle D prime, E prime, F prime, and it has been reflected across the y-axis. Now I have a second method. I can use the rule to find the new ordered pairs. When reflecting across the x-axis, notice that what changes is that the x-coordinates change their values, and they're just going to be the opposite sign. So that is our rule. We take the x-axis and we change the sign and keep the y-coordinates the same. So I'm going to start with labeling these ordered pairs. Point D started at 4, 2. Point E started at 1, negative 2. And point F started at 5, negative 5. And then I'm going to do this rule. I'm going to change all the x-coordinates and keep the y-coordinates the same. It doesn't mean make them all negative. It just means change the sign. So be careful about that. So I get D prime, E prime, and F prime. So I'm going to just change the signs. For D prime, I had 4, 2. Now I have negative 4, 2. For E prime, I had 1, negative 2. Now I have negative 1, negative 2. For F prime, I had 5, negative 5. Now I have negative 5, negative 5. And I'm going to see if they matched what we did on graphing. For D prime, we got negative 4, positive 2. E prime was negative 1, negative 2. And F prime was negative 5, negative 5. They all matched up. So we've got the coordinates, and we have finished this problem. For example 2, we're going to name a rule for the reflection of triangle PQR. So we want to know what is happening. And we can easily tell that it was a reflection across this x-axis because that's what it flipped across. So I'm going to note that it flipped across the x-axis. And so I'm going to figure out what that rule is. I can see that going from point P to point P prime, that I had the ordered pair negative 2, 6, and it became the ordered pair negative 2, negative 6. So the x stayed the same and the y changed the sign. That appears to be my rule, but let me test it on another point. Q was the ordered pair -2, 3, and then Q prime is the ordered pair -2, -3. So once again, the x stays the same and the y value changes signs. And then we'll look at point R. R was at -6, +3, and then R prime is -6, -3. So once again, the x value stayed the same, but the y value changed its sign. So we've named our rule. That is always the rule for a reflection across the x-axis. Notice that when reflecting across the x-axis, the y value changed signs, and up here, when reflecting across the y-axis, the x value changed signs. So we have that rule. We reflected across the y-axis, so we changed the sign of the x value. We reflected across the x-axis, so we changed the sign of the y value. That'll help you to recognize that when you do a reflection, the axis that you're flipping across is the coordinate that stays the same. You always change the other coordinate to the opposite sign. Okay, so one last quick question. In reflections, do the angle measures change? Well, we can tell by looking, for example, in the problem that we just did, example 2, that angle Q started as a 90-degree angle. Angle Q prime is still a 90-degree angle. And the same thing would follow for the other ordered pairs. P and P prime have the same angles as each other. R and R prime have the same angles as each other. So do the angle measures change? No. Angles never change in transformations. They are always the same. Do the lengths of the sides change? Well, I could come back up here and I could just count that for a moment. I'm going to take this measure here. I'm going to see how wide from R to Q is. And I can count. It's 4 units wide. R prime to Q prime is also 4 units wide. So that didn't change. I could also look over here from P to Q. It's 4 units tall. P prime to Q prime is also 4 units tall. It didn't change. And the other 2 line segments appear to be the same size as well. So do the lengths of the sides change? No. Side lengths never change in congruent figures. Remember, they're congruent because the size didn't change. Translations, reflections, and rotations are all congruent figures and never change their sides.